Welcome to a special 15-year anniversary episode of Stories from the NNI. I'm Lisa Friedersdorf, Director of the National Nanotechnology Coordination Office, or NNCO. Today, I am pleased to welcome Mike Metter, Program Element Manager for Lightweight Materials and Manufacturing for NASA's Game-Changing Technologies Program and NASA's liaison to the Nanoscale Science, Engineering, and Technology Subcommittee, which is the coordinating body for the National Nanotechnology Initiative, or NNI. From 2014 to 2016, Mike served as the Director of the National Nanotechnology Coordination Office. In 2010, Mike led a NASA-wide team that developed the Nanotechnology Space Technology Roadmap, a 20-plus year plan for the development and insertion of nanotechnology in future NASA missions. Mike, thank you so much for joining us. To get things started, can you tell us a little bit about yourself and tell us how you got involved in nanotechnology?
Sure. So I've been with NASA since 1983, been formally active in nanotechnology probably since the late 90s. I was the chief of the polymers branch at that time, and we were one of the first groups within NASA to initiate a thrust in nanotechnology. We actually started by hiring a person, recent master's candidate from Case Western Reserve, who had experience in clay nanocomposites, and we took advantage of that experience to start to explore how these materials could be used by taking advantage of their barrier properties for everything from materials for propellant tanks to making high-temperature polymeric composites more stable at high temperatures. In the late 90s, early 2000s, NASA started a long-term relationship with the late Nobel laureate Rick Smalley to basically take his HIPCO process for making single-walled carbon nanotubes and scale that up into making nanotubes in quantities large enough that we could actually make composites with them and start to evaluate their properties. We were privileged to be a part of that group that worked with Smalley, so we had, at the time, unfettered access to carbon nanotubes. We used to get big jars of these crude HIPCO nanotubes. And I was also fortunate to have a PhD student working with me from Clark Atlanta University. She actually worked full-time on a project on carbon nanotube purification and incorporating those materials into composites and evaluating their properties. We also started to expand what we were doing in nano, and we added a person with a pretty strong background in aerogels. And that's actually led to major growth in this area, not only improving the properties of conventional silica aerogels, but also in making aerogels out of polymers. I was also involved in a lot of work with universities in nanotechnology. Back again in the early 2000s, NASA started a program called the University Research, Engineering, and Technology Institutes. And there were, I believe, 6 of these URETIs across the country. 3 of them were in nanotechnology. We also had a couple of research institutes at minority-serving institutions, one at Clark Atlanta University and the Center for High Performance Polymers and Composites. The original focus of that center was on conventional composites, but as nano composites started to become more an area of interest that we were exploring, we sort of shifted the emphasis of that center. NASA also had a Center for Advanced Nanoscale Materials at the University of Puerto Rico at Rio Piedras, and I was involved with that center as well.
From that perspective, can you give us your thoughts on how nanotechnology, how those activities and interactions with universities have influenced or contributed to NASA's mission?
Sure. So NASA recognized the potential benefits of nanotechnology very early on. We were one of the founding members of the Interagency Working Group on Nanotechnology, which was the precursor to the NNI. I mentioned that we funded Rick Smalley's work to scale up the HIPCO process. Rick was a great salesperson for nanotechnology, presented a really compelling case, was a very charismatic leader in that area, and he really convinced NASA leadership that we ought to be investing in that area. And so nano has been an important technology for NASA. We actually have developed a series of roadmaps for how we can develop and apply nanotechnology in NASA missions. It started in about the 2004 timeframe. NASA had a little bit of a hiccup in terms of its investments in R&D in the mid-2005-ish or so. And nanotechnology, along with most other technology developments, took sort of a hit. It got revitalized back in about 2010 when the NASA chief technologist, Bobby Braun, decided that nano was an important thing for NASA to invest in. And that led to an increase in funding in nano, but also a new roadmap that was developed in about the 2011-ish timeframe, and then a revision of that roadmap in about 2014. We've always used nano as a tool in the toolkit to make better materials and better batteries, better insulation, better propellants. And that really has been the way that we have thought about nanotechnology and the way that we've applied it. And so we look to other agencies like NSF and others to really do the more foundational aspects of nano. And we view our role as more, taking that foundational knowledge and reducing it to practice and doing things like scale up and demonstration. We look at nanotechnology for everything from structural materials to batteries, battery electrolytes, battery electrode materials, thermal insulation and electrical insulation, and technology areas like that.
I'm sure our listeners would really love to hear about the cutting edge research that's going on at NASA. Can you talk a little bit about some of the emerging materials that are being studied by your scientists and engineers?
Sure. So I'll talk about a couple of those. The first is carbon nanotube-based composites. This is work that we have been doing for quite some time now with an eye towards making ultra lightweight, high strength composite materials using carbon nanotube, not as a dispersant or an additive into the composite, but rather as the actual reinforcement for the composite itself. So if you could take carbon nanotube fibers, for instance, and use them as drop-in replacements for carbon fiber, then you could place the carbon nanotubes where you want to. You could get much higher concentrations of carbon nanotubes than you could get just by sprinkling them into your favorite matrix resin. You could use conventional processing techniques to make these composites, so that would ease the acceptance by the aerospace industry and their suppliers in adopting this technology. And so we started working with a company called Nanocomp Technologies. At the time, Nanocomp was making carbon nanotube sheets and yarns, and they were looking at those for electrical applications. While we were interested in that, we really thought that the greater potential for Nanocomp's materials lied in how they could be applied in structural composites. And so we looked at both the sheets as sort of a replacement for woven fabrics and also the yarns as a replacement for carbon fiber. And we have worked with Nanocomp pretty much hand in glove over the past 4 or so years to characterize their fibers, put their fibers into composites, give them feedback on how they perform, and they have gone back and tweaked their process quite a bit to improve the mechanical properties. In 2017, we actually made a composite overwrap pressure vessel. This is a gas bottle that's used to store gaseous propellants on the International Space Station and spacecraft. The role of the composite is to really provide structural integrity for the tank. And so we made one out of a carbon nanotube composite outer wrapping and used that as a propellant in a cold gas thruster system on a sounding rocket that was launched out of the Wallops Space Flight Center. It performed like a charm. The second area is aerogels. Aerogels are nanoporous solids. The first ones were made, the ones that are more predominant are made out of silica. They're about 98+% air. They have been used in NASA missions, thermal insulation for all of the batteries for all of the Mars rovers that NASA has launched. And they've also been used in an interesting application in the Stardust mission as a way of capturing the dust from a comet and preserving the structure of those dust particles and then returning those to Earth so we could study not only the shape of the particles, but the chemical composition of those particles.
I'm wondering, you have the development of these really interesting technologies. You talked about aerogels and the CNT composites. What are the opportunities to transfer these technologies to broader use? Can you give us some examples of nanotechnology commercial products that have originated from research and development in NASA labs?
Sure. So NASA patents technologies that we develop in our labs. We make those technologies available for licensing. Other ways that we work with industry are through cooperative agreements and public-private partnerships. So, for instance, carbon nanotube work that we are doing, component of that is some demonstration work that is being conducted with an aerospace prime under a program called Announcement of Collaborative Opportunities. And the idea behind these is that if a company has a promising technology and they would like, for instance, NASA to either help develop it or to help do some crucial testing of that technology that could occur under these ACOs, typically what happens is that there is no exchange of funds between NASA and the commercial partner. Commercial partner develops their technology on their own nickel, and NASA does its part of that partnership under its own nickel, but we share the results with each other and work to further that technology. In some cases, we use contracts with small businesses to further develop technology that's developed in a NASA lab. But in other cases, we might have an interest in seeing what industry is doing and how that might be applied to a NASA mission needs.
Nanotechnology developments are happening across a wide range of different fields. You've mentioned a wide variety of activities that you've been involved in while you're at NASA. Where do you think, as a community, we've made the most progress during the past 15 years?
From a general standpoint, I think we've developed a very strong underpinning of the foundational knowledge that breakthroughs that we've made so far are possible and will lead to new breakthroughs. For example, it's led to precise control of nanomaterial synthesis that's being used to make nanoparticle-based therapeutics and diagnostics for medicine and someday theranostic systems. Better characterization and modeling and simulation is another area that we've made a lot of progress in. Actually, the advent of nanotechnology movement was really spurred on by the development of characterization techniques that allowed us to see things at the nanoscale that we couldn't see without those techniques. So one area where characterization and modeling and simulation is really helping NASA is, again, with these nanotube composites. There's some recent work out of Florida State University in which they determined that it may be that in composites, these nanotubes flatten out. And that flattening may actually contribute to the better strength and performance that we're seeing on some of these materials. And we would not have been able to recognize the role of these flattened tubes if it were not for the fact that we have the characterization techniques now that enable us to see that physically.
So, Mike, you've been involved with the NNI for a long time, and you have served both as an agency representative and as the director of the NNCO. From your perspective, how has the NNI helped to extend the frontiers of nanotechnology research and development since its inception?
Yeah, so I think the NNI has really done a great job of bringing the unique skills and interests of a pretty diverse group of federal agencies and departments together to advance nano. And I talked about, how NASA has really an interest in nano as a tool to make things better that we can then use for NASA missions, and how we rely upon other agencies to often do the more fundamental and foundational work. But by and large, we view our role as taking the discoveries that come from universities and converting them into reality and use of NASA missions. A good example, again, is Rick Smalley developed the HIPCO process to make single-wall carbon nanotubes, not with NASA funding, but NSF funding. And NASA recognized that we needed to have that process scaled up so that we could actually get enough nanotubes, that we could go from having a few hundred milligrams of them to grams of them, so that we could start to put them into composites and see what the effect was. And that's when we funded Rick for about 4 years or so, I guess, to actually do that. And that actually led to his company, CNI. So I think that's one of the major contributions that the NNI has made to the development of nanotechnology. I also think, you can't downplay the role of the NNI in developing a pretty broad network of unique characterization facilities and user facilities for fabrication devices, and that network has supported everything from fundamental research to commercialization. And that's a pretty powerful capability within the U.S. to advance nanotechnology.
Mike, thank you so much for taking the time to talk with us today. Do you have any closing thoughts or additional points you'd like to share with our listeners?
Yeah, it doesn't seem like 2003 was that long ago when President Bush signed the 21st Century Nanotechnology R&D Act. But, a lot has happened in nanotechnology over those 15 years. A lot of exciting developments have taken place. We're seeing nanotechnology in commercial products, everything from the clothing to the cell phone in your pocket to the TV set in your home. And I think that the next 15 years should be even more exciting and productive. And, as we build on the accomplishments of the first 15 years. And I think that the NNI and its member agencies will continue to play an important role in fostering these new discoveries and accomplishments. So I'm really excited to see what's going to happen over the next 15 years.
Thank you for joining us today for this special 15-year anniversary edition of Stories from the NNI. If you would like to learn more about nanotechnology, please visit nano.gov or email us at info@nnco.nano.gov. And check back here for more stories.